Question. DS. Tom deposited $50,000 in a new account with a fixed annual quarterly compounded interest rate. If no transaction was made using that account, what is the total amount of interest earned at the end of the fourth quarter? Condition 1. The total amount of interests earned at the first quarter and the second quarter was $1,005. Condition 2. The interest earned at the second quarter was $505. Solution. Let's solve this DS question using the variable approach. There are three variables in these questions: principal, interest rate, and time period. Therefore, with a DS question, it is very likely that we will have E as the answer. Let's apply 3 steps of the variable approach. Let's follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find the total amount of interest earned at the end of the fourth quarter. If Tom deposited $50,000 in a new account with a fixed annual quarterly compounded interest rate, and no transaction was made using that account. Now, we are given the principal as $50,000, the time as 4 quarters. Let the fixed annual quarterly compound interest rate be R. We are looking for the value of the total interest. Follow the second and the third steps. From the original condition, we have 3 variables, P, T, and R, and equations P equals $50,000 and T equals quarter. To match the number of variables with the number of equations, we need one more equation. Since conditions 1 and 2 will provide one equation each, D is about 60% likely to be the answer. Recall 3 principles and choose D as the most likely answer. Let's take a look at each condition. Condition 1 tells us that 50,000 times of R over 100 plus 50,000 times of whole 1 plus R over 100 whole times R over 100 is equal to 1,005. Therefore, we have only one variable, R, and we can find a unique value of R since R is positive. The answer is unique, so the condition is sufficient by CMT2, which states the number of answers must be 1. Condition 2 tells us that $50,000 times of whole 1 plus R over 100 times R over 100 equals 505. Therefore, we have only one variable R, and we can find a unique value of R since R is positive. The answer is unique, so the condition is sufficient by CMT2, which states that the number of answers must be 1. Also, according to tip 1, it's about 95% likely that D would be the answer when the value of condition 1 is equal to the value of condition 2. Each condition alone is sufficient, thus D is the correct answer. Answer D.